The automotive industry relies heavily on million-dollar molds to shape complex vehicle body panels. Aptera recently bypassed this massive financial barrier completely by utilizing a brilliant new manufacturing loophole. Today, we are looking at an engineering decision that changes everything for small-scale production. Most people look at solar vehicles and only think about battery sizes or total aerodynamics, but the real magic happens quietly on the factory floor during the actual manufacturing process. And that brings us to a very specific piece of curved metal recently spotted online. It was a lamination tray designed specifically for producing the large rear hatch solar panel. Making this part correctly is an incredibly complex engineering challenge due to its unique contours. Have you ever considered how large curved solar arrays are actually pressed together during assembly? They require a rigid backer mold that perfectly mirrors the final shape of the vehicle. Think of it like a giant custom-fitted press for delicate and expensive energy cells. The dashboard solar panels are perfectly flat and quite simple to manufacture in large numbers. We actually saw 8 of those flat panels sitting completed and ready for immediate installation. But the rear hatch is the largest single solar component on the entire vehicle design. It sweeps down the back with precise curves that must match the aerodynamic body flawlessly. If that large mold is slightly inaccurate, the completed solar panel simply will not fit. So how do you manufacture a flawless custom metal mold without spending ridiculous amounts up front? Traditional automakers use immense stamping machines that crush flat steel into rigid, pre-formed heavy dies. Those dies are carved from hardened metal blocks and cost hundreds of thousands of dollars. That enormous expense is perfectly fine if you are building millions of identical standard cars. But Aptera only needs a few high-quality molds to press their specific solar components. Spending $500,000 on a traditional stamping die makes absolutely zero financial sense. You could try carving the mold directly from a massive solid block of raw aluminum, but the resulting tool would be far too heavy to place inside a lamination machine. Lamination machines apply gentle, even heat and pressure. They cannot support massive solid metal weights. So, the engineering team partnered with a specialized company to implement a die-less forming strategy. Now, this is where the manufacturing process becomes genuinely fascinating and incredibly cost-effective overall. Die-less forming completely removes the need for expensive hardened steel stamping molds in the factory. Instead of pressing metal instantly, a robotic arm uses a smooth steel ball for shaping. The automated machine drags this rolling ball across a flat sheet of secured thin metal. It traces programmed paths very slowly while applying direct mechanical pressure to specific surface areas. Pushing millimeter by millimeter, the flat metal begins stretching and bending into three-dimensional shapes. Watching this process unfold is mesmerizing as smooth, sweeping curves appear from a flat surface. This slow, continuous pressure yields incredibly precise automotive-grade parts without requiring massive upfront investments. The trade-off is simply time. It takes much longer than a traditional single stamp. But when you only need 1 or 2 final pieces, that extra time is irrelevant. You avoid the massive financial penalty of tooling while still achieving aerospace-quality manufacturing tolerances. And this single decision highlights exactly why this startup is operating differently than legacy brands. They are not blindly copying the bloated manufacturing habits of massive traditional global car companies. They are finding surgical, efficient solutions that match their exact production needs and current scale. This die-less forming method represents a massive shift in how low-volume production is managed. It lowers the barrier to entry for highly complex physical products in the modern market. Just a few decades ago, building this custom aerodynamic solar mold would be financially impossible. Now, software and robotics allow small, brilliant teams to execute flawless designs on tight budgets. The fact that the rear hatch mold is finished proves they are executing their strategy. We already knew the front hood panels and the roof panels were completely figured out. The final missing piece of the solar exterior puzzle was always that massive rear hatch. Seeing physical proof that this complex mold exists is a major milestone for actual production. It moves the project away from theoretical computer designs and straight into physical manufacturing realities. And they are smartly stockpiling these finished solar panels before the remaining vehicle parts arrive. Stockpiling complex components ensures the solar assembly process never becomes a bottleneck during final production. That shows a deep understanding of supply chain logistics and assembly line pacing in manufacturing. Now, you might be wondering about the temporary nature of that online production update photo. Why share an exciting manufacturing breakthrough only to quietly remove it a few hours later? In the corporate engineering world, this happens quite frequently due to simple vendor communication rules. The supplier might have strict non-disclosure agreements regarding their proprietary dieless metal forming techniques. Or perhaps the partnership was not officially ready for a public marketing announcement just yet. Another possibility is a minor defect was noticed during the first testing of the mold. Engineers might have pulled the photo to verify the tool tolerances before making bold claims. Whatever the administrative reason for hiding the photo, the physical metal tool still certainly exists, and that physical tool represents genuine forward momentum for the entire efficient solar vehicle project. The shift from concept renders to tangible production tooling is the hardest phase of manufacturing. Startups usually fail during this exact transition because they miscalculate the massive cost of tooling. By choosing an alternative fabrication method, they effectively neutralized their biggest financial risk completely today. This level of technical problem-solving deserves far more attention than just quoting range statistics. Everyone loves talking about aerodynamic drag coefficients and how far the car drives on sunlight, but the real victory is finding affordable ways to bend metal into those aerodynamic shapes. Without smart, scalable manufacturing techniques, the most efficient vehicle design remains permanently trapped on paper. Have you ever seen industrial dieless metal forming used in modern manufacturing before this instance? Most mechanical engineers go their entire academic careers without studying this specific low-volume technique. It serves as a brilliant reminder that conventional mass production wisdom is not always mandatory. Different scales require entirely different engineering philosophies to remain sustainable and financially viable long-term. I find this pragmatic approach to problem-solving deeply encouraging for their future vehicle deliveries. They are actively stockpiling finished solar dashboards right now for the upcoming initial validation builds. Once those validation vehicles are fully assembled, physical road testing can finally begin in earnest, and every single validation test brings the final consumer production timeline much closer to reality. The foundation of any successful hardware company is built on these quiet, intelligent vendor partnerships. It is not about flashy press releases. It is about securing reliable tooling and materials. As we track this journey, we must look beyond the surface-level marketing materials presented. The deleted photo gave us a rare, unfiltered glimpse into their actual daily engineering workflow. It showed us a team actively solving complex geometric problems with highly efficient modern technology. Are there more surprises waiting in their supply chain as they finalize the remaining components? I suspect we will see similar creative manufacturing strategies applied to the internal composite structures. When resources are carefully managed, engineering teams are forced to innovate beyond the standard practices. This resourcefulness is the true competitive advantage that allows new companies to challenge established giants. Legacy automakers struggle to pivot because their factories are locked into expensive, rigid tooling systems. A flexible die-less system means designs can be tweaked and improved without replacing massive dies. Imagine the freedom of adjusting a body panel shape by simply uploading new software coordinates. This agility could allow for continuous iterative improvements during the early stages of low production. We are witnessing the birth of a more agile approach to producing complex road vehicles, and the solar arrays are just the first clear example of this dynamic manufacturing mindset. What other unique fabrication methods do you think they are hiding behind closed factory doors? Let us consider the immense scale of what they are attempting to achieve right now. Creating a vehicle powered primarily by the sun requires completely rethinking how parts fit together. Every curve on that rear hatch serves a specific purpose for harvesting daily solar energy. The lamination mold ensures those delicate solar cells lay perfectly flat against the curved surface. If the cells bend too sharply, they lose their efficiency or simply crack under pressure. Therefore, the die-less forming machine must maintain precise dimensional accuracy across the entire metal span. The resulting mold is essentially a flawless cradle for the most important technology on board today. Achieving this level of precision without traditional stamping validates their entire agile manufacturing business model. It proves that high-quality automotive components do not always require massive industrial financial commitments. Slowly but surely, the physical pieces of this highly anticipated vehicle are finally coming together. They are checking off the most difficult engineering boxes before moving to final vehicle assembly. The solar array was always considered the most challenging aspect of their entire production plan. Seeing the tooling completed for the most complex panel provides immense confidence in their timeline. The silent progress happening on the factory floor speaks volumes louder than any marketing campaign. We are watching a masterclass in modern hardware development tailored for very specific market needs. The engineering restraint shown by not buying expensive stamping dies is truly a brilliant move. It keeps the company financially lean while they navigate the hardest stages of automotive production. Every saved dollar extends their runway and increases the probability of successful final customer deliveries. Let me know your thoughts on this highly unusual approach to shaping automotive body panels. Do you believe die-less forming could eventually replace traditional stamping in other specialized manufacturing sectors? It certainly opens up incredible possibilities for rapid prototyping and localized small-batch production facilities. We might be looking at the future of custom manufacturing hidden inside a deleted photograph. The puzzle pieces are scattered, but the overall picture is starting to look incredibly promising. I am continually amazed by the sheer depth of engineering knowledge hidden in these updates. They are not just building a car, they are actively rewriting the rules of production. And that is exactly why this story remains so deeply captivating to follow every week. Stay tuned as we continue tracking these quiet but significant manufacturing milestones in the future. The journey from flat metal to a fully functioning solar vehicle is accelerating very quickly. The dedication required to perfect this single lamination mold demonstrates their overall commitment to quality. They refused to compromise on the aerodynamic shape just to make the manufacturing process easier. Instead, they found a specialized manufacturing partner capable of meeting their exact geometric design requirements. This collaborative approach to problem solving is essential when building something entirely new and unprecedented. And the completed rear hatch mold stands as physical proof that their unique strategy works. We are moving past the era of endless digital concepts and entering true physical reality. Watching flat sheet metal transform into a precision automotive tool is nothing short of incredible. It highlights the beauty of industrial design when paired with highly advanced modern robotic manufacturing. The road to full production is always difficult, but they are clearly navigating it intelligently. By mitigating financial risks early, they ensure long-term stability for the entire engineering program. Every stockpile of finished solar panels represents another step closer to vehicles on the road. The mystery of the deleted photo only adds to the intrigue of their current progress, but the facts remain entirely clear. The physical mold is finished and production moves forward. We will keep analyzing these technical updates because they reveal the true health of production. Understanding these complex manufacturing choices gives us a much better perspective on the final product. It is a thrilling time to observe the evolution of sustainable transportation from the sidelines. Share your insights below and let us discuss the implications of this new forming technology. Community discussions often uncover brilliant details that even the most seasoned manufacturing experts completely miss. Your technical expertise constantly elevates these conversations, making analyzing these small updates incredibly rewarding today. I look forward to reading your theories regarding their next major structural engineering breakthrough soon.